In this video, we'll be taking a look at these four nonparametric distributions. We begin with the uniform distribution. A uniform distribution assigns equal probability to every value between its minimum and maximum. Here I've just arbitrarily chosen a minimum of 5 and a maximum of 10. You would use a uniform distribution as a rough estimate. It gives you a very approximate model when there's little or no data available. Often an expert can at least bound a problem. But this is rarely a good reflection of the uncertainty in a parameter, since all the values in the allowed range between 5 and 10 have the same constant probability density, and that density abruptly changes to 0 once you get beyond the 5 or the 10. So it's used as a very rough estimate. Often if you see a uniform distribution, that's a signal that the assessor doesn't really have a very good idea of what that value would be. You can also use the uniform distribution at times as a crude sensitivity analysis. For example, if I had a distribution and I didn't know the mean of that distribution, I might insert a uniform distribution as the argument for the mean. And this would enable me to look and see how important that uncertain parameter is. On rare occasions, there could be a variable that has a uniform distribution. If we're talking about a hard drive spinning and where the spinning would stop, those sorts of things, they can be represented by a uniform distribution, but that would be relatively rare. Let's turn now to the triangular distribution. The triangle distribution basically constructs a triangular shape from 3 input parameters. I've used the same minimum 5, a maximum of 10, and a most likely value of 8 here. The triangle is another rough modeling tool where you would know the range and the most likely value within the range. There's no theoretical basis for the triangle. It derives all of its statistical properties from its geometry. The triangle that's proven to be a very flexible kind of distribution, because if you change the most likely value here, let me change that to a 6, you see the distribution shifts its shape rather handily. So a triangular distribution is a bit of an improvement over the uniform in that it tells you which value within the range is more likely than the others. At-risk also offers us a distribution called the Trigen distribution. The Trigen distribution is useful because often it is difficult to estimate the minimum and the maximum value with any degree of certainty. When you're working without good data, it's often very hard to estimate the minimum and the maximum. So what happens in this distribution, look at the parameters here. We have a bottom parameter instead of a minimum of 5, a most likely of 8 as we had before. Excuse me, I was trying to get rid of those little tags here. The top value is a 10. So we've changed from a minimum and a maximum to a bottom and a top. And here's the other bit of the parameter information. Notice that the bottom number of 5 has a percentile associated with it. I've arbitrarily stuck in 5 percentile there. So I'm saying I don't know what the true minimum is, but I think there's about a 5% chance that it's beyond 5. Likewise, I don't know what the maximum is, but there's about a 95% chance it's beyond 10. So if the minimum and maximum are a particular concern to you in your problem, you would be better off using a Trigen distribution and adjusting these percentages as needed. The last distribution that we're going to take a look at here is the Pert distribution. The Pert distribution uses exactly the same parameters that the triangular distribution does. It gets its name because the Pert distribution uses the same assumptions about the mean as Pert networks do. Now you would have to take a look at the formula for the mean to understand that, and that's not our concern right now. There are mathematical differences between the triangle and the Pert, and the Pert is basically a version of the beta distribution. It requires the same three parameters, but it derives its properties from that distribution formula. The beta Pert, as it is sometimes called, is used exclusively for modeling expert estimates. This is where the expert offers a minimum, a most likely, and a maximum guess. It's an alternative to the triangle, so let's take a look at what this would look like compared to the triangle. I'm going to add an overlay by clicking on this Add Overlay, and I'm going to choose a triangle here. And now let me close this. And you can see that the triangular distribution with the same parameters puts more weight on the values in the tails and less weight on the values at the shoulders of the distribution. The shoulders would be this area here around the mean, around the expected value. So if you believe you're dealing with a variable that is more likely to return values near the minimum and maximum, or bottom and top, you would prefer one of the triangular distributions, either the triangle or the Trigen. And if you're dealing with a variable where you feel values are more concentrated around the mean, then you would use the Pert distribution. These are four very handy distributions to use, and you'll find that they come up very well when you're working with relatively little data.